Lesson 11.1, Part B, Defining and Using Series. A series is the sum of a sequence. So it's just adding up all the values of a sequence. So 2, 4, 6, 8 was a sequence. 2 plus 4 plus 6 plus 8 plus ... is a series. We can write series using summation notation, or sometimes called sigma notation, because it uses the Greek letter sigma. For a finite series, it would be like this: 2 plus 4 plus 6 plus 8. Well, the E looking thing is the sigma. It's actually Greek capital letter S for sum. And we have this little I. It's called the index of summation. It's our variable. Notice it matches the I over here in our formula. So that is our rule, and the variable must match the index of summation. The 1 is the lower limit. That's the number we start with. So notice, so I take a 1 and I plug it in, I'll have 2 times 1, which is 2. And then we put a plus, and then we plug in the next number. 2 times 2 is 4, plus 2 times 3 is 6, plus 2 times 4 is 8. Notice the 4 on the top. That is called the upper limit, and that is where we stop. You stop when you plug that in. If it was infinite, the upper limit would be infinity. So let's write some series as sigma notation or summation notation. So the first thing is we actually have to come up with a rule. All right, so our rule, well, it looks like our pattern is we're adding 4. I'm going to guess that that holds. So our first number is 4. Our second number would be 4 plus 4. Our third number is 4 plus 2 times 4. So this is like 1 times 4 and 0 times 4. So our rule appears to be 4 plus, and this is n equals 1 and 2 and 3. So it looks like the numbers here that are changing are 1 less than the n. So it'd be n minus 1 times 4. Distribute. And you can see it comes out to be an, those cancel, equals 4n, which you might have just gotten. That's 4 times 1, 4 times 2, 4 times 3. If that's the case, up here is 4 times 25 for the 100. All right, so our summation notation. You write your sigma, the rule goes there. Now I just happen to write down an n, so I'm going to use n as my index. And where do I start? What was my first n? Well, we said the first n was 1. And what's the last n? It's 25. Why don't you pause this and try number 25. Remember, start by finding your rule. Patterns adding 3. So again, it's 7 plus 0 times 3, 7 plus 1 times 3, so 7 plus 0 times 3, 7 plus 1 times 3, 7 plus 2 times 3 to get to 13. So your rule is 7 plus n minus 1 times 3, because again, n starts at 1, but it's a 0, so I have to subtract 1. So it is 7 plus 3n minus 3, or 4 plus 3n. So if you write it as a summation, again I used n as my index. I'm starting with n equals 1, and it's 1, 2, 3, 4, 5 terms. We'll stop when we plug in the 5. So let's actually calculate a summation. Let's find the value. All right, notice here k starts at 5. So I'm going to start by plugging in a 5. And then we can plug in the next number, a 6. And then plug in the next number, a 7. And then plug in the next number, an 8. And then the next number, which is 9. And then the next number, which is 10. And we stop there because we're stopping when we plug in the 10. It's not 10 terms. It's after you plug in the number 10. And you could simplify that. It'd be 25 plus 1 plus 36 plus 1 plus 49 plus 1 plus 64 plus 1 plus 81 plus 1 plus 100 plus 1. You put it all in your calculator and you come up with 361. Why don't you try number 39? Pause it. All right, you start by plugging in a 2, so it's 2 over 2, and then a 3, and then a 4, and then a 5, and then a 6, and then a 7, and then an 8. And you could add that together by finding a common denominator. Good luck with that. I mean, it's not going to be that hard. But yeah, it'd be fun. It's probably easier if you put it in your calculator and you end up with 481 over 140, which is approximately 3.436. So you ask, are there any shortcuts? Well, of course there's some shortcuts. Notice for each of these, the index starts at 1 and we're going to n. So here, we're just adding 1. So it'll be 1 plus 1 plus 1 plus 1 plus 1 plus 1 n times. So it's just 1 times n. Here, this would be this one is I, so this is 1 plus 2 plus 3 plus 4 plus 5 plus. And this one would be 1 squared plus 2 squared plus 3 squared plus 4 squared, and so on. But they only work when you start at 1, and they have either 1i or I squared. So we can use those formulas to find a sum of the series like this one, because notice it starts at 1. And it's nothing funny, it's just k squared, or like I squared. We can do some fun little bits, though. We can separate this into 2 separate sums. And we can do that because it doesn't matter which order you add. I can add 3 times 1 squared plus 2, plus 3 times 2 squared plus 2, or I go 3 times 1 squared plus 3 times 2 squared plus 2 plus 2. Still the same thing. And since I'm multiplying 3 times the k, I could factor out the 3. And here I could, this is like 2 times 1, so I could factor out the 2. Because it's multiplied by each one of those things, we can factor it out. So now we've got these nice little formulas. So the first one, the formula was k for k squared or I squared, was the n times n plus 1 times 2n plus 1 over 6. And for the 1, it was just n. But what was n? N was 10. That's the number on top. So this is the same thing as 3 times 10 plus 1, which is 11, times 2 times 10 plus 1, which is 21, over 6, plus 2 times 10. And you can probably put that in your calculator and get 1,075. Why don't you pause this and try that one? It doesn't start at 1. So what could we do? Well, if we're starting at 10, this could be the same thing as adding up all the numbers 1 through 25, but then subtracting the numbers. Well, if I only want 10 through 25, I'd subtract the 1 through the 9. And then we use our shortcut formula. Since it's just I, it is n times n plus 1 over 2. And I have this twice. But here, n is 9. First one, n is 25. So I'll have 25 times 25 plus 1 over 2 minus 9 times 9 plus 1 over 2. Put that in your calculator, you get 325 minus 45, which is 280.